Alright class, yesterday you should have mastered or have a good grasp on the four states of matter. That was solids, liquids, gas, and plasma. Plasma was the newest state of matter that we throw in 8th grade. However, those states of matter can undergo phase changes. Most of the material I'm teaching today you should have learned in 6th grade earth science about the water cycle. But I want to throw in some bigger, fancier words now that you're in 8th grade. Today's learning target is to compare and contrast endothermic and exothermic phase changes or reactions. Here is a list of those. We're going to compare melting, evaporation, and sublimation versus freezing, condensation, and desublimation, which is also known as deposition. What you should already have with you are the following notes that I handed out. I'm going to start out by giving you the vocabulary words of endo and exothermic, and you'll fill in your slotted notes. As we go through this, everything on the left-hand column is going to be an endothermic reaction. Everything on the right-hand column is going to be an exothermic reaction, so I'm going to bounce back and forth because these are opposites. You should have already heard of melting and freezing, and those are opposites. I'm not going to scroll down and go to the notes right here. I'm going to use my PowerPoint. So let's get started. What does endothermic mean? Out beside the word endothermic in your notes, you should know endo means inside, and therm or thermic refers to heat. So what that means literally when you break apart that word is heat is added inside or taken in. So if you are taking in heat, it makes sense that the substance is going to get warmer or hotter. So again, in your notes, I'll be walking around. You should write inside for endo, break apart this word, and thermic means heat. Exothermic reactions, just like an exit sign, exo means to leave, exit, or be removed. Thermic is heat, so out beside that word, please write exo, exit, therm, heat, so therefore heat is removed or taken away. Therefore, the substance, if you remove heat, it will get colder. These are called exothermic reactions. Look at the following picture. Do you think this would be endothermic or exothermic? I'll give you a second to decide. If you chose endothermic, you would be correct because this ice cream was taking in heat. Therefore, it's getting warmer and melting. Again, endothermic is heat is adding, the ice cream is melting. So let's go over our first phase change. The first phase change, finding your notes where it says melting. Melting is when a material goes from solid to liquid. So that would be like an ice cube melting into water. We would say that thermal energy is added, so this is an endothermic reaction because heat is going inside. Candles also melt. Wax melting is another good example. Try to draw pictures if you have space provided. The opposite of melting would be freezing. So freezing would be taking liquid water and changing it to a solid like an ice cube. Thermal energy, heat is being removed, so we call that an exothermic reaction. Melting was endothermic, freezing is exothermic. So when we make slushies or you get ice buildup, this is a freezing or exothermic reaction. Please note that diagrams are important. The melting point equals the freezing point. So on a temperature scale, if you're moving up in temperature and you cross that point, it would be the melting point. But if you're decreasing temperature and you cross that same point, we would call it the freezing point. Those points or temperatures are the same for whatever type of material. You should know that water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. You may want to make a note of that. The next phase change we're going to talk about is evaporation. In the water cycle in 6th grade earth science, you should have learned that evaporation is when liquid changes to a gas, when it's below the boiling point. So basically lakes can have water that evaporates off the surface, oceans do that. If you set a cup of water outside, it will naturally evaporate. And that's because energy is added. If heat energy is added, we would say that evaporation is endothermic. Some people get confused and don't realize there's another form of evaporation that we call vaporization. It's like evaporation, but it's when you're at or above the boiling point, when you just get the vapor. It's still liquid to gas, but vaporization takes out the E part. It's still endothermic, heat is added, but when you get boiling water or it produces steam out of a kettle when water is boiling, that is above the boiling point, and that is called vaporization, when you actually start seeing the gas vapors forming. It's still kind of like evaporation, but vaporization is a different phenomenon. It's endothermic still. So here is the difference in a nutshell. Liquid to gas below the boiling point is evaporation. Liquid to gas at or above the boiling point is vaporization. Both are endothermic. The opposite of evaporation would be condensation. So look at your notes. On the other side, the opposite of evaporation is condensation. So instead of liquid to gas, we're going gas to liquid. Thermal energy is removed, so this would be an exothermic reaction. The object is getting colder. That's how water droplets form on leaves in the morning. If you put a cold Coke can in a room, it starts to get water droplets on the outside of that can or that glass of water you see on the bottom right. All of that are condensation droplets. That is gas to liquid exothermic. This chart should look familiar, but it's different. If I were to give you a graph and ask you to label this point, if we are adding heat, we're going to usually use red and arrows. If we're increasing temperature, that is endothermic. That would be evaporation point or boiling point. If we are going backwards in temperature and we're cooling an object off, we usually dictate that by blue arrows, which represents cold, or we're removing heat. That would be the condensation point. The boiling point and condensation point of liquids or gases is the same. It's what direction you're going on a graph. So be able to label that when I give you a graph at your closing today. Now here comes the hard part. This is new for 8th grade. Say sublimation. Sublimation is when we skip a phase of matter, when we go straight from a solid all the way to a gas. This is very rare and very few substances can do this. It has to be extreme heat or a particular substance. This would be endothermic if you were going from solid straight to a gas. That means you skip liquid. Dry ice is one of the best examples that we can talk about that is endothermic and sublimation. If you've ever been to a concert or sometimes you go to church and they'll have the fog machines, they usually put dry ice or material in there that will produce a fog on stage, and it will leave behind very little liquid as the ice melts. So the ice was a solid, it's dry ice. And then when it melts, it skips liquid phase and goes straight to gas, and you get this fog. Also, freeze-drying objects and iodine crystals are a good example of sublimation. The opposite of sublimation is called desublimation, but there's another word that means the same thing, so I need both of these in your notes. The other word is deposition. Everybody say deposition. I could also say deposit is the root word. So we're depositing something. We're going from a gas straight to a solid. I'm going to say it again. From a gas, skip liquid, straight to a solid is deposition or desublimation. Energy is removed. That means heat is removed. So heat is exiting. This is exothermic. In sub-freezing air, water vapor changes directly to ice without first becoming a liquid. This is how we get snow. This is how frost forms on the ground. Think deposition. So those clouds are making a deposit on the ground. There were gaseous clouds in the atmosphere that had moisture. They turned straight to a solid, and that solid in the form of snow, sleet, or hail falls to the earth, and it's deposited on the earth. That's desublimation. What does all this mean? Heat or kinetic energy can cause a phase change. We can graph that. Endothermic and exothermic reactions can be graphed. What we need to know is when we add heat, molecules speed up. That means the kinetic energy increases when we add heat. Density, however, will decrease. Think about it. If you had an ice cube and you melt it, it is no longer a solid. The density decreased. It's now a liquid. If you keep heating it up, it becomes a gas, so density decreases. Please put a star by those 3 bullet points I just went over. Compressibility means to squish. When we add heat, we can compress gases into a container. So think about an air compressor that a mechanic uses. They can compress that gas, large volumes, into a small container because it's squishable or compressible. Those are endothermic reactions. What about exothermic? When heat is removed, again, put a star by these bullet points. When you make something colder by removing heat, that's how your air conditioner in your house works. It removes heat, which makes things colder. Molecules will slow down. Kinetic energy will decrease. Density will increase. If you took a liquid and you froze it, the density increases because you went from a liquid to a solid. However, if you try to squish a solid, that compressibility decreases. You cannot compress solids like you can liquids or gases. That would be the end of our lesson, so let's talk about what you're going to do the rest of the day. Once you've filled out those notes, there is a chart or table I need you to work on. It looks like this. It is the notes from yesterday. You are going to draw a picture of a solid using the particle arrangement. Some of you had that wrong in your notes. You're going to talk about how volume changes. Does it have a definite or indefinite shape? Does it have a definite volume, indefinite volume? How do the particles move? What is the kinetic energy? That is solids, liquids, gas, and plasma. Once you're done with that, this quiz is right here. It's the same one yesterday. If you have not finished that quiz, it is for a grade. You must finish that today. You may begin.